Since the Middle Ages, scientists have developed sophisticated new theories about the enormity of the universe and our place in it. Theories that often have no room for God.
Many phenomena have appeared mysterious or miraculous or magical. And then through the process of science, we've eventually understood them. Scientists gradually realized that the sun really is just one star among a multitude of stars in a gigantic galaxy, having hundreds of billions of such stars. And all this was created in a Big Bang 13.7 billion years ago.
But while scientific theories, observations, and experiments tell us where we are in the cosmos, they don't answer the eternal questions: why we're here, and who, if anyone, created us. So some physicists continue to search for those answers. What they're finding is extraordinary. A remarkable unseen order that may govern the universe.
We're all struck by the beauty and majesty of the natural world about us, the trees and the sky and the beauty of a sunset. It is awesome in its majesty. How can we make sense of it all? We need to look at the hidden subtext of nature, the mathematical relationships that underpin it, forming a sort of shadow world. Some people think of this as like a cosmic code.
Regardless of whether or not they believe in God, most scientists agree the cosmic code appears to exist.
Everything in the universe is determined by the fundamental forces of nature. The strengths of those forces are characterized by numbers called fundamental constants that are so sensitive that if they changed by just a little bit, the universe as we know it wouldn't be here. For example, if the rate of expansion of the universe right after the Big Bang had changed by 1 part in a quintillion is 1 with 18 zeros after it, the universe would continue to expand or collapse back on itself, and none of this would be possible. To illustrate just how small a number 1 part in a quintillion is, imagine all the grains of sand on this beach. In fact, imagine all the grains of sand in all the world's beaches. That number's probably somewhere around a quintillion. In this analogy, if all that sand represented the rate of expansion of the universe right after the Big Bang, how many grains of sand would I need to add or subtract to wreck the universe? Just 1 grain, 1 in a quintillion. That's how precise things had to be for us to be here.
But even though the Big Bang was perfectly calibrated, intelligent life would never have formed if matter had spread evenly across the universe.
Had it been perfectly smooth, then there wouldn't be any clumps which would gravitate and form stars and galaxies. So we needed slight irregularities in the distribution of matter in the universe. Had those irregularities been much smaller, stars and galaxies wouldn't have formed. Had they been much larger, everything would have collapsed to form black holes.
But even with the right distribution of matter throughout the universe, life would still never have formed without a complex series of processes inside stars that converted helium and hydrogen into heavier elements like carbon that form the basis of all living beings.
Some of those stars explode, providing raw material with which to form new stars, planets, and ultimately life. Had the laws of physics been a little bit different, or even if the physical constants had been a little bit different from what they really are, this process of nuclear fusion and the explosion of stars might not have been possible, and we wouldn't be here discussing it.
I don't know a single scientist who would disagree with the statement that the world is exceedingly ingenious. Not just mathematical, not just beautiful, not just elegant, but the manifestation of something truly extraordinary.
How How could this extraordinary fine-tuning of the universe be anything less than unmistakable evidence of a divine creator? So while it appears a divine creator planned the universe, many physicists say apparent fine-tuning doesn't prove anything of the sort. Something else must be at work. But what, other than God, could possibly explain the remarkable series of events that led to the creation of life in our universe? One very popular contender is an idea that seems at least as incredible as the idea of God. It's the multiple universe theory.
A very large number of universes, perhaps even an infinite number, could in principle exist in a vast hyperspace.
We can understand the idea of hyperspace by comparing it to a mug of beer.
The beer mug would be the hyperspace, and the bubbles would be these individual universes. The bubbles in a beer mug are all physically about the same. But suppose they span a range of properties. Some of them might have carbon and oxygen, and stars and gravity, and others don't. We would be in one of the ones that leads to a rich, complex universe culminating with life as we know it.
If there are an infinite number of other universes, the fine-tuning that seems to be present in ours isn't an example of God's plan, but rather the law of statistics. Most of these universes wouldn't naturally develop in ways that fostered intelligent life, but a few would.
So there's a big question if you're just kind of trying to assess how likely is it that we'd find a protein by chance with all the amino acids in that prebiotic soup interacting with each other for, say, billions of years. And I give it a lot of time. How likely is it that we'd ever get a protein to arise by chance? So I have a colleague who's been interested in the whole question of whether or not life could arise by chance for a long time. His name is Doug Axe. He's a molecular biologist. He did his PhD at Caltech. He worked for 14 years at Cambridge University, and he wanted to find out how common or how rare are the functional sequences of amino acids among the big space of all the possible amino acids there are. And he came up with a really amazing number, and it's 10 to the 74 power. So just to get the amino acid sequence properly, you've got an odds of about 1 in 10 to the 74. But there's other probabilistic hurdles that have to be overcome. If you want to build a protein, we know from chemistry that you have to attach the amino acids together with what's called a peptide bond. In nature, peptide bonds occur with about a 1 in 2 in a 1 in 2 frequency. Half the bonds that form between amino acids are peptide bonds, half aren't. But if you get any bonds forming that aren't peptide bonds, you can't form a protein. So to form a protein, 150 amino acids long, you've got a 1 in 2 chance at each site of getting the correct type of linkage. So you got 1 in 2 times 1 in 2 times 1 in 2 times 1 in 2 to the what power? Close to 150. Since we got linkages, we have 149, but call it 150, okay? So in other words, we got another huge exponential problem to overcome. So, and it turns out that 1 in 2 to the 150 is the same number as 10 to the 45th, 1 in 10 to the 45. So now we got 2 incredibly improbable things that we've got to overcome to build a functional protein by chance alone. One more problem. When you're building proteins, amino acids come in 2 flavors. There's a left-handed flavor and a right-handed flavor. They're called optical isomers, not flavors, okay? And the left-handed version is the only kind that can be used in building proteins. You get even one right-handed amino acid in there and your protein won't fold properly. So you got another probabilistic hurdle to overcome. So you've got a 1 in 2 chance at each site again, out to the 150th power. 2 to the 150th power, again, is 10 to the 45. Oh my goodness. So the odds of building even a short functional protein by chance alone is 74 plus 40. You can remember how you do this in math? You can add the exponents if you're multiplying exponential numbers.
164.
Thank you very much. Okay? Wow. Now, can anyone get their mind around a number that big? There's only 10 to the 80th elementary particles in the entire universe. There's only 10 to the 16th seconds since the Big Bang. There's only 10 to the 139th total events since the beginning of the universe. Now you're starting to get the understanding of why people are very skeptical that the chance hypothesis is going to do the job. Now, you may have heard just the opposite. Has anyone ever gotten in a discussion with you about the origin of life and said, hey, it happened by chance? I mean, do you hear that? I mean, this happens to me. I'll be lecturing in hostile university environments, and I'll get done and somebody say, well, but, and they want to argue with me about the probabilities. And I just shut the discussion down because I say, no serious scientist thinks this is the way it happened. No serious scientist thinks this is the way it happened. No serious scientist thinks this is the way it happened. No serious scientist thinks this is the way it happened.
وفي الأرض آيات للموقنين وفي أنفسكم أفلا تبصرون وفي السماء رزقكم وما توعدون فرب السماء والأرض إنه لحق مثل ما أنكم تنطقون